Hello friends, so today we will learn Gibbs free energy. So this Gibbs free energy is represented by capital G, or this is also called as Gibbs function. It's a UPAC name. So we will see the how this change in free energy is related with spontaneity. As we know, spontaneity of a process is affected by the two thermodynamic quantities, that is they are the H enthalpy and S is the entropy. If we put these two quantities together in such a way that a single function whose sign will determine whether a reaction will be spontaneous or non-spontaneous, and this problem was actually solved by one scientist that is called J. Willard Gibbs, and he introduced a new quantity that is called Gibbs free energy, that is G. So let us see how what the method he applied. So actually Gibbs showed that for a reaction taking place at constant pressure, constant temperature, so delta G represents that portion of total energy change that is available, means that portion of total energy change which is available, that is called free energy, and which energy used for utilized for doing some useful work other than pressure volume work. For example, change in free energy of a reaction is equal to minus 300 kilojoules. What does this mean? This means that it is possible to obtain 300 kilojoule of useful work from the reaction. Conversely, we can say that if delta G is plus 300 kilojoule, this means at least that much energy in the form of work must be supplied to make the reaction take place. So thus Gibbs free energy, that is G, is defined as the thermodynamic quantity of the system, the decrease in whose value during a process, means it will decrease in which the value during the process is equal to the maximum possible you have to mark this point. So maximum possible useful work that can be obtained from a system. So this is that thermodynamic quantity. So mathematically it is represented as G is equal to H minus Ts. So this is the mathematical representation of the free energy, where H is the enthalpy, T is the absolute temperature, and S is the entropy of the system. So this derivation is actually derived by there are different methods. So we'll discuss the two methods. So first method is that from this law, thermodynamic law, H is equal to E plus PV. Okay, so this is the one mathematical equation, this is the second mathematical equation. So if you equate it, if you put the value H E plus PV into over here, so from equation 1 and 2 we can write G is equal to E plus PV minus Ts, and for a free energy change at constant temperature and constant pressure, so we can write delta G is equal to delta E, and this PV is written as the P delta V, or delta P into V minus T delta is written as the T delta S, change in S, and minus delta Ts. Now at constant temperature this will be 0, and at constant pressure this will be 0. So we will get ultimately value delta E plus P delta V and minus T delta S. So this delta E plus P delta will be nothing but this is equal to delta H minus T delta S. So this is the Gibbs Helmholtz equation. Second way we can see that for isothermal process, this G is written as the G1 H1 minus T delta S Ts1 for the initial state, and if you want to take the final state, so G2 will be your H2 minus Ts2 for the final state. If you subtracting this second minus 1, G2 minus G1, so we will get H2 minus H1 minus T into H2 minus H1. So we can convert into delta G is equal to delta H minus T delta S. So this equation is used to discuss during force. So it will discuss the driving force. So what is driving force? That is the overall criterion for spontaneity of a process. So this delta G will decide the type of reaction, whether the reaction will be spontaneous or non-spontaneous. Physical significance of Gibbs free energy change, that is free energy and the useful work. So from here we will discuss this significance. So by first law we know that delta U is equal to Q minus W, means work is done by a system, that is when heat is absorbed we will write this equation. Now in this case work is there, we have two type of work, one is the expansion work, one is the non-expansion work, or we can say non-mechanical work. This non-mechanical work is called as the useful work, and P expansion is P delta V. Let us take one example. suppose in during the electrolysis of water, okay, under the constant pressure, what happened to electrolysis water? So this water will convert by passing electricity. It will convert two type of gases, that is the 2 moles of hydrogen, 1 moles of oxygen. So what happens? So this become 3 mole. 3 mole means volume of the system is increases. Now here we will see under these two processes we are getting two type of work. One is the non-expansive work, one is the expansion work. Non-expansive means non-mechanical work. What is non-mechanical work? So this non-mechanical work is actually the work which causes decomposition of water. And for mechanical work, P delta V, in this what happens, the expansion of volume of the system take place. Means electrical work is non-PV work, or you can say it is non-expansive work or non-mechanical work. So this work is actually called as the useful work. So thus we can write delta U is equal to Q minus work expansion minus work non-expansion. So this work is divided into two type of work. So this work expansion is PV work, so we can write like P delta V, and this will be minus work non-expansion. So Q is equal to, just rearranging, so Q will be this side and this will go delta U with addition with delta U in left hand side. So Q is equal to delta U plus P delta V plus work non-expansion, and this is nothing but the delta H plus work non-expansion. The whole will be converted into delta H. Now from the second law, for a reversible change taking place at constant temperature, we know that delta S is equal to Q reversible by T, and Q reversible nothing but the T delta. So we can see from here. So we have to substitute this Q reversible over where? This one. If you substitute Q reversible, so this will convert into T delta S. You can say T delta S is delta H plus work non-expansion. So we can again rearrange. So this will come this side. No, sorry, work expansion. So this will come this side and this will come this side. So delta H, if you put left right hand side, this becomes delta H minus T delta S, and this will becomes your this side. This will be minus work non-expansion. So this minus non-expansion is called as the delta G. So this delta is nothing but the that work other than the work expansion. So this work is actually called as the useful work. So hence decrease in Gibbs free energy, it is decreasing. So decrease in Gibbs free energy, the delta G, it is actually the measuring the useful work, maximum possible useful work. I am marking maximum possible useful work or non-expansion work done by the system. So whenever this free energy increases, definitely the work will also will be greater amount. So this becomes your maximum at maximum changes energy. Now if the work involved is electrical work, as in case of galvanic cells, then as electrical work, then we can write this non-expansion work is equal to NFE. Then delta G will be, delta useful work is nothing but is equal to NFE, or we can write what is N. N is the number of electrons involved in the reactions per mole during the electrical work in galvanic cell or electrochemical cell. What is the E is nothing but the EMF of the cell, where F is the Faraday. 1 Faraday is equal to 96,500 Coulomb. So at a standard state of free energy, that is 298 Kelvin and 1 atmospheric pressure, so we can write minus delta G standard is equal to NFE standard. What is delta G naught? It is a standard free energy change, and E naught is the standard EMF of the cell. So in a fuel cells, it is found that the heat evolved, that is delta H, that is heat evolved, is not completely converted to energy, that is useful work given by delta G. So we can write the ratio delta G upon delta H is nothing but the efficiency of the fuel cell. Let us take up one example to understand this work done involving galvanic cell. The EMF of a cell reaction is this reaction: zinc plus copper will zinc copper dye positive in aqueous state converted to zinc 2 plus aqueous solution plus copper is 1.1 volts. So calculate the free energy of a reaction. If enthalpy of a reaction is this much kilojoule per mole, so calculate the delta S of the system. So what is delta S? So delta G naught is, this formula is there, minus NFE is, from this we can find out the free energy of the reaction. And now free energy nothing but the delta S naught minus T delta S naught. So from here we have to find the delta S naught. So this will be delta H minus delta G upon T. Substituting the value, delta G we know that, delta H we know that, and delta H we know that. We will get the answer minus 14.76 joule per Kelvin per mole. So this is the change in entropy. This change in entropy is in negative, it is decreased down. Now we will see the spontaneity in terms of the free change. How spontaneity will take place in terms of free change. So we have two conditions. So we'll see these two conditions one by one. So first is when the so deriving the criteria from the entropy consideration. We have to take the first entropy consideration. This is the first case. So we know that a change in total change in of the change of entropy of the universe, or total entropy change is nothing but the change of entropy of a system plus change of entropy of surrounding. When the system is not isolated, then this is the entropy change of a process. So let us consider that the process at constant temperature, constant pressure, where the QP, that is the heat lost to surrounding. So when heat is lost to surrounding, so QP of surrounding is positive and QP of the system becomes your negative. So when QP of system becomes negative, so we can write enthalpy of the system is also negative. So we see this is the equation 1. So this is the equation your 1. And this is the equation 2. So the delta S of surrounding will be equal to QP surrounding by T. So minus delta S of system by T. So from 1 and 2, so 1 is your this one, not this one, this is the not 1. This is your delta S total is equal to delta S plus delta surrounding. So from 1 this one, from 2 this one. So we can substitute the value of this one. QP surrounding delta S, okay, so over this one. So we can delta S total, delta S of system minus delta S system. So from surrounding will be this much, so we can write minus delta S system by T. So now multiply by T by this one, delta S total will be equal to T delta S system minus delta H of system. This is the third equation. So delta system, it will come this side. So here minus, you take minus this one. So this will be your plus, this will be your minus. So delta H of system minus T delta S system. Now, what does give Helmholtz equation says that delta G is equal to delta H minus T delta S, and T delta S nothing but the T delta S of the system. So we can put delta G of system is equal to, take the system of this one, system, this one, system. This is nothing, T delta G of system is equal to delta H of system minus T delta S of system. So this is the equation number 4. Now T delta S system is, we already know that is the TS total, and this is the T delta S of system minus T delta S. So we can substitute this 4. So 1 is 3, 1 is 4. So from 3 and 4, delta G of system is equal to T delta S of total. Already there. If you substitute this value over here, this one over here, so this will cancel. So you will get this much value. And we know that for a spontaneous process, what happens? A total entropy of the system, change entropy of the system is always equal to 0. So delta G is equal to negative. So in this way, it comes that delta G of the system is always equal to negative for a spontaneous process, because the total entropy of the process is greater than 0. So definitely this will be a spontaneous process. So we can say that for a spontaneous process, T delta S of total will be your positive, then only delta G is negative. So but in terms of total entropy change, like we have two cases. So in terms of total entropy change, case number 1, if delta H is negative, then T delta S will be your positive. Then what happened? Delta G is negative, this whole value will be positive, then whole value will be your negative. This process is your spontaneous process. In this case, we have to consider delta S total should be your positive. Second case, if you are taking delta H positive and T delta S your negative, then delta G will be your positive minus this negative. So this is negative, this is positive, so you will get the overall positive. So this is your non-spontaneous process, or we can say direct process, and its reverse process may be spontaneous. In this case, delta S total is your negative, then it is possible. Third case is that when the both tendency is equal in magnitude, means that delta H is equal to T delta S, both are positive. Then in that case, delta H is your T delta S, means these both are equal, so delta G will be equal to 0. So in this case, what happens? The process is said to be in equilibrium conditions. Now we will see the second criteria, means deriving the criteria from Gibbs energy equation. So again, Gibbs has two factors, delta H and T delta S. So this is the energy factor and this is the entropy factor. Means this factor will have a tendency for minimum energy, and this factor having a tendency for the maximum randomness. then we will have different possibilities of this equation. Delta G is equal to delta H minus T delta S. So I have written in the form of this one. This is delta H, this is T delta S, and these are the conditions, and this is the delta G. Case 1, when this is negative means this is favorable, and T delta S negative, this is unfavorable, means entropy is negative. So in this case what happens? Condition, first condition, delta H should be greater than T delta S. So if this is greater, we can see this is negative, it's a more negative value, so definitely this will be delta G 0. Delta G will be negative, this process will be spontaneous. If T delta is your greater than the magnitude of delta H, in this case this will be your non-spontaneous, and because delta G will come positive value, and this only happens when temperature is high, and in this case it only happens when the temperature is low. Third case, when both are equal in magnitude, then this becomes 0. Delta 0 means the process is in equilibrium conditions. Case 2, delta H is positive, means unfavorable endothermic reaction, and T delta is positive. So both are positive, but this is favorable, this is unfavorable. Again, case 1, more magnitude of this is greater than T delta S when the temperature is low. So this will be your non-spontaneous, and delta G will be your positive because both are positive. Delta H is greater than T delta S since this is positive. If magnitude of delta H is less than T delta S, so the only possible when temperature is high. So in this case again it becomes spontaneous, and delta G will be your negative. So this is negative, so this will be a spontaneous process. Third case, both are equal in magnitude, so this is again delta G will be 0, and this is equal, the process will be in equilibrium condition. Third case, delta H is negative is favorable, and this is positive is also favorable, both are favorable. Then this is your highly spontaneous. So in this only condition this will be highly spontaneous because delta is very high. So at all temperature it will be spontaneous. And case 4, one is positive, other is negative. This is unfavorable, this is also unfavorable. Then this will be your highly non-spontaneous because delta G is highly positive at all temperature. So in short we can say delta G negative is spontaneous process, 0 means at equilibrium, and delta positive means non-spontaneous process. It may occur in the backward direction also. So we can see in this shortcut all notation I have written here. So effect of the sign of delta H, delta S and T on the spontaneity of a process. So delta H, delta S, and this is your temperature, so we can see, and this is the spontaneity condition. So one is minus, one is plus, so temperature can be any. Delta G will be always negative, this will be your spontaneous. This is example. If this is positive, this is negative, so temperature can be anything. This will be always positive, this will be non-spontaneous. Both are minus, it happens when the temperature is low, a spontaneous process. Both are minus when temperature is high. So this spontaneous process can be converted into non-spontaneous. You can convert non-spontaneous process into spontaneous by decreasing the temperature. If both are negative, if both are positive, delta H, delta S, this will be your when temperature low, then this is again non-spontaneous. Again you can convert into non-spontaneous spontaneous if you keep the temperature high. Both are positive. So this is the example for this one, this is the example for this one. So there is another way to represent the delta G is equal to delta H minus T delta S. So this is the one small chart. So this is delta H, this is the plus, this is minus, this is delta S, plus minus. So plus minus, plus minus. So plus means if both are plus, two things happens: spontaneous at high temperature, non-spontaneous at low temperature. If plus minus, it will be spontaneous at all temperature. In this case it is plus, this is minus, it will be non-spontaneous at all temperature, and both are minus means high temperature non-spontaneous and low temperature spontaneous. Now let us solve one numerical, some numericals. So a heated copper block at 130 centigrade loses 340 joules of heat to surrounding which are at room temperature of 32 degrees centigrade. Calculate delta change in entropy of system, change in entropy of surrounding, and total change in entropy. Assume temperature, block and surrounding is constant. So Q system is given, that is minus 340 because energy is losing by the system and surrounding is gaining energy. So we can write change in energy is Q system by temperature. So minus 340 by this is the Kelvin. You will get this much joule. For surrounding, Q surrounding by T surrounding, this is positive value. You will get the positive, and totally nothing. Just add it. You will get this much value. This is very simple questions. You can try. You can practice by using this question. 10 kilogram of cold water at 2 degrees centigrade absorbs 50 joule of heat from the surroundings, which are at a temperature of 37 degrees centigrade. What is the change in entropy of the system, change in entropy of surrounding, and change in entropy of the whole universe? So these are the answers you can verify. So now we'll again take up the next topic. What is the role of temperature on spontaneity of process? So again, spontaneity of a process depends on two factors. One is the enthalpy and the entropy factors. So this enthalpy does not change much by the change in entropy, but delta S is changed by the temperature. How? Let us see that. If the reaction is endothermic, so what happens? Delta H is positive, this is unfavorable because this is exothermic, this is endothermic. So if T delta S is negative, in this case, if this is positive, but if this is negative, the process will be your non-spontaneous. Okay. And if T delta S is your positive, so if this is positive, the process will be your spontaneous. Means if T delta S is greater than magnitude of delta H, so this process will be nothing but the entropy driven. So this is driven by the entropy. And let us see this how T delta is affected by temperature. So there are three conditions for this one. If temperature is low, then T delta will become less than delta H. In this case, what happens? Delta G will be your positive. We have to use the equation delta G is equal to delta H minus T delta S. So definitely if this is very less, so definitely what will happen? Delta G will be your positive. So this is non-spontaneous. If T delta S is lesser than magnitude of delta H, so delta H is again negative. So negative means it will be spontaneous but slow process. If temperature high, so definitely this is more high, this will be more negative. So entropy become a spontaneous process become very fast. So this is your nothing but the entropy driven. This is actually called entropy driven. Means we can convert the endothermic reactions which may be non-spontaneous at low temperature. So we can see at low temperature is non-spontaneous, but same as can be converted into spontaneous at high temperatures. If this low temperature is increased by the high temperature, this process becomes your spontaneous. So this is the main significance of this equation. Now second is the for exothermic reaction. So for exothermic the delta H is negative. So if T delta S is positive, the process will be again spontaneous. Let us write delta G is equal to delta H minus T delta S. So this is negative value. So if this is positive, this will be spontaneous definitely. If T delta is negative, so again condition is that magnitude of H will be greater than T delta. This condition, that this is called as the enthalpy driven. This condition is enthalpy driven and process will be again spontaneous. So again magnitude of this whole process will be greater than this one. So delta G will be positive. So if this is much more than greater, high value, so delta G becomes here again positive than this one. So this is your non-spontaneous process. Okay. And if this whole value is become lesser than delta H, okay, so the whole value lesser, then definitely what will happen? This is your negative value. So this is what happens. This is become again delta G is negative. So this is your again a spontaneous process. This happen only at low temperature. This happen only at high temperature. So an exothermic reaction may be non-spontaneous at high temperature. It can be become spontaneous at low temperature. So we can convert this non-spontaneous process which is high temperature, so it can be converted into a spontaneous process when you decrease the temperature low. So this is the basically significance of spontaneous and non-spontaneous process during the endothermic and exothermic reactions. Now we will see the standard free energy of a reaction and standard free energy of formation of a reaction. So like change in enthalpy and change in internal energy, we cannot determine the absolute value of free energy because this is the extensive property. So standard change in free energy can be defined as the free energy change for a process at 298 Kelvin and 1 atmospheric pressure. So when the temperature is this one and 1 atmospheric pressure in which the reactors in their standard states, then that is called as the standard free energy of a standard free energy change. Like that, standard change in enthalpy, standard change in free energy can be calculated from the sum of the free energy of the standard free energy formation and sum of the standard free energy of the reactions. So this is the equation. Standard free energy change in free energy is equal to summation of standard free energy formation of product minus summation of free energy change or formation of the reaction. This is the reaction, this is the product. So sum of the standard free energy of the product minus sum of the standard free energy of the reactant. So let us take one reaction. Suppose this is general reaction A, B and C. They are the coefficient. A, B and C D are the coefficient of the reactants. We can add the standard free energy of this reaction is nothing but the summation of the free energy of the product like this one minus summation of the standard free energy of the reactant. So C into free energy of the C plus D, this is the D. So free energy of D minus A into free energy of A minus plus B into free energy of the B. So change in standard free energy formation may be defined as the free energy change from 1 mole of a compound is formed from its constituent elements in their standard state. So standard free change in free energy formation in standard state for element will be always 0. So this you have to remember. This will be help in calculation during the reaction.